Very good morning to all of you.
Good morning, ma'am.
Good morning, ma'am.
Kindly acknowledge when you see the screen.
It's visible, ma'am.
Okay. Now see, you guys were there under me with the DS subject, right? In our data structure subject, we had one chapter called graphs, in which we have already discussed shortest path algorithms. So there were total 3 kinds of algorithms. Okay. Prims and Kruskal's, they are known as your MSTs, minimum spanning trees. Correct? Then anyone remembers the remaining 2? Warshall, correct? And Dijkstra's. Okay? The 3 algorithms that we have already seen in your 3rd semester. That's why I told you that it is going to be a memory test today. So I'm not going to take the test. 3 different algorithms that we use to calculate your shortest path between the vertices of your graph. Okay, that is a minimum spanning tree, Dijkstra's algorithm and Warshall's algorithm. Alright? Minimum spanning tree, we already discussed your Prims and Kruskal's. Okay? Though I think most of you were not there, but fine. Even if you are not there, you will get it because in our previous unit in this semester, it is already covered. Okay? So I am skipping that stuff here. Yes, it is covered. Today we are going to discuss your Dijkstra's algorithm. Alright? Now what and why do we use this algorithm? What is this algorithm first of all? To find the shortest path. Okay? But the catch is shortest path from a fixed source. Okay? In your Dijkstra's algorithm, your source will be fixed. And from that fixed source, you are going to find what is the shortest path from your variable destinations. Right? Like, for example, Nepal is your fixed source. You want to start from Nepal. Right? And you want to reach to Rajkot. Let's say. So how many possible ways you can reach to Rajkot if you come via road? Not via air. If you come via road. So that can be 3. Right? Either you travel from Nepal to point 1, point 2 and Rajkot. You come to Nepal, from Nepal you come to point 1 and directly to Rajkot. Correct? There can be several ways. But which one is going to be the shortest way for you? That is what this particular algorithm will help you. Okay? So one thing that you need to remember and understand here is the source is going to be fixed. Destinations can be variable. Okay? Like for example, from Nepal I can reach to Delhi. From Nepal I can reach to Shillong. From Nepal I can reach to Rajkot. From Nepal I can reach to Kanyakumari. Okay? So my destinations are variable. Delhi, Rajkot, Kanyakumari, Shillong. But source is fixed. Okay? And suppose I choose any one distance from my fixed source. From Nepal to Kanyakumari, suppose I want to go. Then what are the possible shortest distance I can take to reach Kanyakumari? That is what this Dijkstra's algorithm is going to tell you. Understood? Online students, any questions?
No, ma'am.
I hope the concept is clear. What we are going to discuss, I hope everything is clear. Okay? And for the same reason, because your source is fixed, so for that same reason, your Dijkstra's algorithm is also known as single source shortest path algorithm. So if by chance in the exam one marker comes, what is another name for Dijkstra's? You guys should not be leaving it blank. Okay? and also try to learn how to spell this algorithm. Okay, students are spelling it as Dijkstrax, Digicrax. It is not Digicrax or Dijkstrax. It is Dijkstrax algorithm. Okay, Dijkstrax algorithm. All right, because in the Viva, when the question comes that give all the algorithms or name all the algorithms to find shortest path, people are saying MST, Warshall, and Digicrax. It is not Digicrax. Okay, so try to learn the spell. All right, it is Dijkstra's algorithm. All right, remember this. This is the main formula for your Dijkstra's algorithm. We have discussed in the past two examples, one with directed graph, one with undirected graph. The example that you can see right now on your screens is your undirected graph. Okay, again you have to read the question carefully. Suppose this is the graph given, okay, and it is asked you to find out the shortest path from vertex 0. So that means 0 is a fixed source, and from 0 you have to find out all the variable distances of the remaining vertexes. Okay, so how you will start solving this? You draw this diagram first of all from the question, and in the question you see, is anything mentioned about any source to be taken? If it is mentioned, then you take it as that vertex as your source. For example, in the question, if it is mentioned that take 8 as your source, then you have to start from 8. Each and every operation you have to start from 8, vertex 8. But if it is not mentioned, then you have full liberty to start from any vertex whichever you like. Okay, so you read the question. Here in the question, you can see I have only given you the diagram. I have not mentioned anything about from which source you can start. So you can pick any vertex. Suppose I am picking up 0 here. So this 0 is my source right now. Okay, this 0 is my source right now. All right. Now, whatever calculation I am going to do, I am going to do with respect to source 0. Like from 0, if I want to reach till 7, then what will be my shortest path? Okay. From 0, if I want to reach till 8, then what will be my shortest path? See, if you can just see here, simply if you just observe the diagram, you can simply calculate these distances, 4 plus 8 plus 7 plus 9. That will give you some value. Again, you can check 8 plus 1 plus 7 plus 6 plus 2 plus 10. Okay, 8 plus 7 plus 6 plus 2 plus 10. Or you can go by 4 plus 8 plus 2 plus 6 plus 2 plus 10. So there are several combinations to reach till 7 from 0, right? But which one will give you the shortest distance? So you don't have that much of time to go and check. And that's why that work is done by the algorithm. And the formulas that you can see, they are the important ones. So I want online students to at least note these formulas or at least take a screenshot for your reference. If you write it down, it will be helpful to you, online students. Offline students already wrote the formula. If not, please write down. It is a condition. If this is true, then we have to do this. If that is not true, then we don't have to do anything. Written? Okay. Now introduction to each of the term. Please listen to me very carefully. What is your U? Source. Okay. So U is going to be the vertex value here. So I am going to start from vertex 0. So what is my U value? U is going to be 0. What is your V? V is the destination. Okay, for which you are going to calculate the distances. Alright. What is C of UV? The term C of UV, the cost to travel from source to the destination. And what is D of U and D of V? Distance of vertexes. Distance of source vertex, distance of destination vertex. Now starting to solve this sum. Initially, what is the first step? You note down this formula. Okay, everybody has to write this formula first. Draw the diagram, write the formula. Okay, step number 2. In your diagram, at each of the vertex, mark infinity except your source. Don't mark infinity at your source because that is the starting point and that will be 0. Okay, for the rest of the vertex, everywhere, write infinity. Okay, at each of the vertex except your source. At source you are going to write what? 0 because that is your starting point. Okay, now check from your source vertex 0. How many vertex can you reach directly? 2. And which are your directly reachable vertex, online students? Which are the vertexes that you can directly reach? 1 and 4, correct? So, yes. So, one value of V will be vertex 1. Another value for V will be vertex 4. Okay? And you have to calculate the distance, vertex distances, D of V. Okay, these infinities you have to update. So, starting from U0, V1, distance of U, that means distance of 0, vertex 0, that is what? 0 plus, what is the cost to reach from 0 to 1? 4. And what is the distance at 1, vertex 1 currently? Distance at vertex 1 currently?
Infinity.
Infinity. Correct. So 4 summation if we make 0 plus 4 is 4. 4 is less than infinity, that is true. That means this if condition is true. So in that case what we have to do? So go to your then. If this is true, 4 is less than infinity is true, then what I have to do? I have to update the distance of my destination vertex. So what is it? 4. So cross this infinity and write 4 there. Okay? Do you guys recall this? If little also, then also it is good. Repeat the same process for vertex 4. Okay? So U is equals to 0, V is equals to 4. D of U is what? 0. Cost to reach till vertex 4. 8. 8 less than distance of 4. Infinity. Currently, it is infinity here. Right? So 0 plus 8 is 8. 8 is less than infinity, true. So go and update the distance of 4. So instead of this infinity, now the distance is what? 8. Followed? Online students?
Yes, ma'am.
Okay. With this, we can say that we explored our source currently. Okay? The sum is not over. We just explored one vertex. Like this, we have to explore each and every vertex. Okay? And then we can find out that what will be our, you can say the shortest path, the shortest distance. Okay? So now next, how you will choose which one is going to be a next source? Anyone remembers? How will you choose which one will be your next source? Correct. Anmol, right? Correct. Current updated? No, Ravi, not current updated. You have to see that out of all the remaining vertex which are not explored, which one is having the minimum vertex distance. So if you see, the vertex distance of vertex 1 is 4. Vertex distance of vertex 4 is 8. And rest all the vertices have infinity as the value. So obviously infinity is not going to be the one which we are going to choose as the as our shortest one. So vertex 1 is having the minimum vertex distance, right? Yes, Ashish, correct. So your vertex 1, okay, will be your next source. I'll highlight it. This one is going to be your next source. Now tell me guys, students, tell me, from 1 directly, how many vertexes can I reach? Is it so? I'm just simply asking, how many vertex can I reach from 1? Directly if I want to reach, directly. Don't see whether they are explored, unexplored, don't see that. From 1 directly, which vertex can I see? You students are still thinking about unexplored vertices. Correct, Arafat. I am telling how many vertices can I directly reach without right now getting the judgment of whether they are explored or unexplored. There are 3 vertices. From 1 I can reach to 0. From 1 I can reach to 4. From 1 I can reach to 2. The reason? They are undirected graph. I don't have to follow the arrows. That's why from 0 to 1 I can go. From 1 to 0 also I can go. Okay. So ideally you have 3 direct vertices from 1. Now you guys were correct when you were telling 2 and 4. The reason is you were not considering 0 because it is already explored. So that is right. Okay. When you are selecting 1 now, you won't go and explore 0. The reason 0 already explored. So your V values, your U value is going to be 1. And your V values, you guys are absolutely correct. Okay. It will be 2 as well as it will be 4. Okay. Again, you have to follow the same procedure of this formula. Now D of U, right now D of U is what? U is 1. So D of 1, what is it? 4. 4 plus 8, that is 12. 12 is less than infinity? Yes. So go and update the value here, 12. Okay. Now my destination is vertex 4. 4 plus 11, that is 15. Distance at 4 is 8. 15 less than 8, false. So do nothing. This 8 will remain as it is. Followed? Or was it quick one? Rest of the students online?
Yes, ma'am.
Okay. So with this, 1 completely explode. Again repeat the same process. Choose the vertex which is having the minimum vertex distance to pick as your source vertex now. So which one is the minimum one now? Which one will be your next source vertex? Have a look again. Observe. Online students, which one will be your next source vertex? After 1. 8 is infinity. Don't give me the distance value. I'm asking about source vertex. Correct, Ravi. Kencho, it won't be 2. 2 is having distance 12. Vertex 4 is having distance 8. Okay, so vertex 4 is what we are going to select. Okay, this vertex name I am asking. So, next to be explored is 4. Now have a look. How many V values can you get from 4? How many V values can you get? 0, 1, 8 and 5. In which 0 and 1 you are not going to consider. 8 and 5 you are going to consider. Okay, so V is equals to 8 and 1 time V will be equal to 5. Right? So give me the updated distance at 8 and 5, students. What is the updated distance at 8? 15. And at 5, you have 9. Correct. Everybody. Yes, absolutely right. Okay. So that means 4 explode. Again choose which is the next vertex. Which one is going to be your next vertex? 5. Absolutely right. Okay. What will be the V values that I have to do for the calculation? Don't give me all the values. Just the V values that I need to calculate. U is equals to 5. V is equals to 8 and 6. Do I have to make any change at 8? I have to update any values at 8? 15. Do I need to update? 9 plus 6. That is 15 only. So no change. Correct, everyone. Online too. Correct. No change at 8. What will be the distance? Vertex distance at 6. 9 plus 2. 11. So cut this out. Write 11. With this, 5 explode. The next one will be 6. Next vertex. Because 11 is the lowest one. So U is equals to 6. What will be the V values? 2, 3 and 7. Correct. V is equals to 2. V is equals to 3. and v is equals to 7. For v is equals to 2, what will be the distance? Do I need to update the distance? No. The reason 11 plus 4 is 15. 15 not less than 12. So no need to update. For v equal to 3, 11 plus 14, 25. 25 less than infinity. So yes, I will write 25 here. Okay. And for v is equals to 7, 11 plus 10, 21. 21 less than infinity. Correct. So 21 is the updated value. Okay. So with this, 6 also explode. Now which one will be the next? Observe the diagram and tell. Students online, observe the diagram and tell me which one is my next vertex. Correct. Vertex 2. So u value is 2. What will be my v values? Three and 8. Correct. Okay. So from 3, 12 plus 7, that is 19. 19 less than 25. Correct. So update to 19. For v equal to 8, 12 plus 2 is 14. 14 less than 15? Yes. So update to 14. With this, 2 is also explode. Next, 8, 3, 7. The lowest is vertex 8. But all the vertices which are directly reachable from 8, they are all explode. So you don't have to do anything here. So that means 8 is also explode. Now from 3 and 7, next one will be what? 3. Vertex 3, correct? Now from 3 you can go to 2, but no need to do that, already explored. From 3 you can go to 6. No need to go there also, already explored. The unexplored is 7. So 19 plus 9, 28. 28 less than 21, it is false. So no need to do anything. Again, 3 explode. And last one will be what? 7. So you got all the vertex distances now. Correct? Everybody followed this example. Now this example was Ashish, your network is low. No, I thought you are typing and I didn't get any message here. Please don't make me open out your background app. I can see. Okay. And I stopped for like 5 seconds and you were not aware. Rest all of them were aware and everybody was watching you that you are typing. And I didn't get your message here, so obviously it was not in the meeting. Happens. It's okay. But don't do it. Okay. This example was to give you the practice and a grip on this particular formula. Okay. Now in the next example, where you have a directed graph. Okay. Here again, you have to look in your question whether they have specifically specified your source, because here that information is valuable. Here you cannot go from A to B and back B to A. The reason this is a directed graph. That was undirected graph, so you can come back and forth. But here, this is a directed graph. You have to look at the arrows. Okay. So suppose I tell you that your A is the source. Okay. This vertex A, I am keeping it as my source. So from vertex A, I have to find out the shortest distances. But the approach here will differ a little bit. The representation. What you will do is, whichever is your source, suppose source is mentioned as, here I am taking it as A. So you will form one table, okay? And in the table, the first value of your column, you will mention it as A. Okay? Now see, again, don't think that, okay, alphabetical order, A is the first one, that's why madam is taking their A. In my question, A is mentioned as the source, so I am taking A. In the examination or anywhere else, if it is mentioned that E is the source, E for elephant, okay, then you write E as the first entry column. Then you can write randomly whichever letters you want to write. Like for example, right now I am writing A, then B, then C, D, and E. Okay. This sequence you can change. You can write it as you want. But you can't write A in middle. The reason it is my source. Okay, so that A has to be the first one in the column. All right. So right now I'm following this pattern A, B, C, D, E. All right. And initially in the first row, what you are going to write is everywhere A to A, obviously it is going to be 0. Rest all the distances, as I have not found out anything, will be infinity everywhere. Okay. Now applying those formulas again. You have to apply those formulas which you applied in the previous slide. Okay. And here there will be one column where you are going to keep the record of your selected vertex. Okay, selected vertex V. So first selection obviously will be my source vertex, because I am finding the distance from my source. So have a look at the arrows. From A, which vertices can I go? From A, which vertices can I go? B and C, right? So I am going to calculate the distances for B and C. So for B, 0, this is right now 0. Okay, this is right now infinity. So 0 plus 10, that is 10. 10 less than infinity, yes. So update it. So from infinity, the value that you are going to update is what? 10. Now coming to C, 0 plus 5. So you are going to update it to 5. D and E, you can't reach directly from vertex A. There is no arrow to reach from A to D directly. Via you can go, okay, but directly you cannot. So you are not going to do anything here. You can keep it blank, or you can write infinities also. All right. Now, which vertex is having the minimum distance? C. So C is the next selection. Okay. C to A, you don't need to write because there is no arrow. C to B. Okay. Now see what is the distance currently at B? 10. Okay. Currently the distance at C is 5. So 5 plus 3 is 8. So you need to update that. So this will be updated. Okay. C to C, the distance will be same only 5. C to D, yes, I can go. So 5 plus 9, that is what? 14. And C to E, I can also go directly. So 5 plus 2, so that is 7. Now out of all these three, 8, 14 and 7, which one is the lowest distance vertex? E. Okay, so next selection will be of E. Now from E you can go to A. Okay, what is the value at E? 7. Now A is already explored here, so you don't need to go there. Though there is an arrow, you don't need to go there. So no need to change anything here. Online students, just a second. Okay. Now from E to D, can I go? Yes. So 7 plus 6, that is what? 7 plus 6, 13. And that is less, so I can update. Correct? So E completely explored. Now which vertex is remaining to be explored? B and E, B and D both. See, first we explored A, then we explored C, and then we explored E. So remaining is what? Your B and your D. And in both of them, the distance, shortest distance is of B. So next selection will be B. Okay. So you are going to explore this B. Now from B, you can go to D. That is 8 plus 1, that is 9. So again, you can update here. Rest, you can't go anywhere from B. Right? So you're not going to update anything there. Now the only remaining vertex to be explored is what? D. Rest everyone is explored. So complete. Your calculation completes here. Tracing is left. No, in previous, this table was not needed. The reason is this is directed graph. Previous one was undirected graph. Okay. Now suppose, let's say from A, I want to travel to D. Okay. From A, I want to travel to D. Then how will I do the tracing? With the help of the table. D for Denmark. Okay. From A, I want to travel to D. Now, if you look at the graph, you can get several paths. 10 to 1, A, B, and D. Right? You can get A, C, B, D. You can get A, C and D. But which one will give you the lowest value? So you can look at the table. Reverse traversal. Okay, reverse tracing. Last value D, 9. Go one row up. It is still 9, so no need to change. Go one row up. Okay. Here there is 13 and there is 8. So when the value changes, you have to pick the vertex which is having the lowest distance. It is what? D. So first it was D, correct? Then from D and B, which is the lowest value? Which is the lowest value? B. Okay, so cursor will go here. Again, go one row up. Okay. Again, the value is not changing, so remain in the same column. Again, go one row up. Value changes. Okay, so you have to look which one is the lowest value. 5. So that is C. Again, go one row up. Value changes again. So you have to look at the lowest value. Which one is the lowest value? For A, 0. So what will be your path? A, C, then B, and then D. And if you calculate the distance, A to C 5, C to B 3, so 5 plus 3 8, and B to D, that is 1, so 8 plus 1 9. And if you observe, you will get that this path is the shortest one. Okay?
In the last one, you have become 9 or
Because D to D, the distance is 9, and all the vertices from D, they are completely explored. So no need to change anything. D to D distance is written. D to D 9. It won't be 0 now because for D we have updated the distance previously. Okay? That's your Dijkstra's algorithm. Everyone, clear? Because B is yet to explore at that point. After I explore E, how many vertices were remaining? B and D. So that's why that 8 is written in row E. No, Ravi, you can't start from any index. If it is provided in the question that you have to start from a particular index, then yes, you have to start from that index. If not mentioned, then yes, you can start from any index. Yes, it will differ. That's why most of the time in the question it is mentioned what is your source. What was your Dijkstra's algorithm? Just a second, students. Okay. Any doubts in this? What? Yeah, I did mute one because my laptop battery is dead. Clear, everybody. You guys have any doubts anywhere in the operations of Dijkstra's algorithm? 8 marks. 8 marks. Less possibility 6. Okay. 6. Okay. 6 with the given source. Alright. Right?
Yes.
Source will be given.
Source will be given.
99%.
99% the source will be given to you. Because if you take different sources, then each student can take any other source, so answer will be different. What if D is the source?
That
Then it will be possible. Then the errors will be changed. If D is the source, then.
See,
See, if you think in a
practical
practical way also,
if
if
you
you
are
are at some, isolated island,
yeah,
your D
D
is
right now
right
the
now that
island,
isolated island.
you can
You can
just
just
reach
reach
to
to
that.
that.
Okay,
Okay,
you
you
can
can
be
be
dropped.
dropped from air. But then you don't know to swim, so you can't swim back to land. Right? So that is the isolated island there. So if D is the source, definitely you will have some way to reach at least to one land. Okay. Online students, things are clear to you? Please answer in the chat, everyone. Okay. With this, I'm wrapping up your session here. Next session will be your Warshaw's algorithm. Okay. And if time remains, then topological sort. They are our last two topics in this unit. And with that, we'll be finishing the unit also. So in this week only, we are I did not get the question. Steps written for the solution. No, steps is not written for the solution because we solved it together here in the class. So it was expected that you guys were noting it down. All right. So if you want for the next session, you can revise your Warshaw's algorithm. Okay. If you have notes of your data structures, then well and good. It will be very easy for you to cope up with me in the next session. Otherwise, we will discuss it and we will see that algorithm again. And with that, if the time remains, then we will also see the last topic of this unit, that is topological sort. Okay, a very small topic and an easy one also. So probably I am not going to rush, but probably if we finish early, then I'll take that, and with that the unit will also be completed. So 6 units will be over out of 9. All right, students, thank you for attending the session. Please write your enrollment numbers and you are free to leave.